Welcome back to Through Inquisitive Kids. My name is Karen, and in this lesson, we will be learning all about the basic properties of linear equations. Use properties of linear equations to solve linear equation-related problems. This is part 2 of the first lesson, Introduction to Linear Equations. Learning goals. Understand the basic properties of linear equations and be able to use the property of equality to solve simple linear equations. Introduction. Here we have a balance. What conditions must the weights above satisfy in order to balance on the balance? Here we have weights. As you can see, there's different sizes, meaning there's different masses to each of them. So in order for it to be balanced, what conditions must each side face? And as you can see, each of these weights are exactly identical. So there's a small one, a medium one, and a medium one, and a large one, and a large one. So in order for it to balance, each side must weigh the same. Basic properties of linear equations. Comparing balances and equations, what can you find? Here we have a balance. We can think of the left side of the balance as the left side of the equation, and the right side of the balance as the right side of the equation. And we can think of this middle part here as the equal sign. So if you think of an equation as a balance, you can regard their expression on both sides of the equal sign as the weights on both sides of the balance. So we're comparing weights to expressions. The establishment of the equal sign can be regarded as this balance. What characteristics does the balance have? Well, if you add weights of the same mass to both sides of the balance, both sides are still balanced. And if you subtract weights of the same mass to both sides of the balance, if you're taking away these weights, the balance is still balanced. So in other words, adding or subtracting the same algebraic expression to both sides of the equation will still maintain the equivalence of both sides. So you can make changes to an equation as long as you're adding or subtracting the same expression to both sides. So this is the first property of the linear equation. Take notes of this, and we will be coming back to it quite soon later in this lesson. So mathematically, we can write it as if A is equal to B, then A plus positive or negative C is equal to B plus positive or negative C. Now here is the property 2 of the linear equation. Here we have another balance. And I want you to look at this animation very closely. Okay, now we're taking away the same thing. So here is property 2 of the linear equation. If we multiply both sides of the equation by the same number, because you see how at first, I don't know what it was, exactly how many, so there were one red on the left side and one orange on the right side, and that was balanced. But then, so we already know that those two things are balanced and are equal in mass. And then, if you multiplied both sides by 6, because now there's 6 of red on the left side and 6 of orange on the right side, they still are equal because you multiplied 6 to both sides of the equation. And now it's dividing. So now you have 1 again on both sides. You divided each side by 6. So that is an example of division. So property 2 of the linear equation is multiplying both sides of the equation by the same number or dividing by the same non-zero number results in an equation. Remember, always be sure to write dividing by the same non-zero number. In mathematics, the language is all about being precise. Because in lots of places, if a divided by a non-zero number, so this is universal throughout the world, dividing by the same by zero is seen as undefined because you can't divide a number by zero. So you have to really be sure to say divided by the same non-zero number, really emphasizing that. So mathematically, if A is equal to B, then AC is equal to BC. So multiplying both sides by the same expression, which is C. And if A is equal to B and C is not equal to 0, then A divided by C is equal to B divided by C. Try. Using the knowledge you've just learned, fill in the appropriate algebraic expressions on the horizontal lines and explain which property of the equation it is based on. If x plus 2 is equal to y plus 2, then x is equal to blank. Well, since both sides have plus 2 and it's equal, it means x is equal to y. And this is using property 1, which is adding and subtracting the same formula from both sides of the equation will result in still an equation. If 4x is equal to negative 8, then what is x equal to? Well, both sides are a multiple of 4, right? Negative 8 is just 4 times negative 2. So if both sides are multiplied by 4, you can divide both sides by 4, and then 4 is not 0, so that's fine. You can divide, and x is equal to negative 2. And this is based off of property 2, which says if you multiply each side of an equation by the same algebraic expression or divide by the same non-zero algebraic expression, then it still is an equation. If 5x is equal to 2x plus 2, then 3x is equal to blank. Well, here you might see, 5x and 2x. So that kind of relates to 3x because you can subtract 2x from both sides of the equation. So 3x is equal to 2. This is property 1 of the linear equation. Remember, you don't just have to add or subtract constants, which is a single number. You can also add or subtract expressions. Example 1. There are two equations. The first one is if ax is equal to b, then x is equal to b over a. And the second one is if x is equal to b over a, then ax is equal to b. Which of the following is correct? Since the result of multiplying the same expression on both sides of the equation still results in an equivalence, then equation number 2 is correct. When dividing the same non-zero expression on both sides of the equation still results in an equivalence, so number 1 is wrong. Therefore, the correct answer is B. So if you chose B, you were correct. Practice. Which of the following equations are valid? Pause the video by yourself and use the notes you've learned that you took on the two properties of linear equations to solve this problem. Okay, so the correct answer is B. If A over C is equal to B over C, then A is equal to B. Let's look at each of these options. If AC is equal to BC, then A is equal to B. So we don't exactly know if A is equal to B because what if C was 0? You have to really say if under the circumstance that C is not equal to 0, then A is equal to B. Let's look at why option C is not the answer either. If A squared is equal to B squared, then A is equal to B. Let's think about this. So what this really means is A times A is equal to b times b. So a times a is equal to b times b. That's not true. Not true. Because this only works if say a and b were opposite numbers or if they were both 0. So you can't be sure. Because what if a was say equal to 1 and b was equal to 3? So that would not work. And it only says, and this does not fit under property 1 or 2 of the linear equation. It does not add or subtract the same expression from both sides of the equation, and it does not multiply an expression on both sides of the equation or divide the same non-zero expression on both sides of the equation. Yes, it did multiply to both sides, except that it was not the same expression. So C is incorrect. D. If negative 1/3 of x is equal to 6, then x is equal to negative 2. Well, let's think about this. If you want to find x, then you should multiply both sides of the equation by negative 3 to cancel out the coefficient of x. So the left side, the coefficient would be canceled out and you would just be left with x. And on the left side, you would have 6 multiplied to negative 3. And that would give you negative 18. So that does not work. Solving linear equations with the properties of linear equations. Example 2. Solve the following two equations. The first one is x plus 2 is equal to 5, and the second one is 3 is equal to x minus 5. I'm pretty sure that you can solve this problem if you have been paying attention for the past, all the things we have talked about just in the lesson. So pause the video by yourself and try to solve this. Alright, so for the first one, this is what the solution should look like. By subtracting 2 from both sides of the equation, so x plus 2 minus 2 is equal to 5 minus 2, right? This is property 1 of the linear equation, and x is equal to 3. Just simplify both sides. By adding 5 to both sides of the equation, we can eliminate this negative 5 on the right side because it cancels out. Simplify, and then we have x is equal to 8. The solution of the equation should be written in the form of x is equal to a, x being the variable and a being the solution to that equation. And this is just something we all universally agree on, this standard form for the solutions of an equation. So you always have the variable on the left side and you have the solution on the right side, because it doesn't really make sense to have 8 is equal to x because you first have the variable and then you solved it. So x is equal to 8. And even if you say it, it sounds better to say, so our variable x is equal to 8, rather than saying 8 is our variable x. Now there's 2 more expressions we would like you to solve. Pause the video again and do your best to solve them using the 2 properties of linear equations. Alright, so for number 3, you should get this. Divide both sides of the equation by negative 3. So we are dividing both sides by negative 3, and then we're canceling out the coefficient of x on the left side of the equation. Simplify, and we have x is equal to negative 5. For number 4, add 2 to both sides of the equation. Negative n divided by 3 minus 2 plus 2 is equal to 10 plus 2. So we want to first, so this is a bit complicated, there's 2 steps to this. First, we want to get rid of the negative 2 on the left side of the equation. So what we do is we add its opposite number to both sides of the equation to eliminate that. After simplification, we have negative n over 3 is equal to 12. Now, in order to get rid of the coefficient of n, which is negative 1/3, we can multiply negative 3 to both sides of the equation. So we have n is equal to negative 36. Here's our conclusion. Using its properties to solve linear equations is to essentially transform a linear equation into the form of x is equal to a. For x plus a is equal to b, you can first subtract a on both sides of the equations to get x is equal to b minus a. For the equation such as ax is equal to b, where a is not equal to 0, you can divide both sides by a to get x is equal to b over a. Notice, 1. Both sides of the equation must participate in the same operation. Number 2. The expressions that are being added, subtracted, multiplied, or divided from both sides must be the same expression. You can't plus 2 to one side and plus 5 to another side. Number 3. The divisor cannot be 0. I'm stressing this again. The divisor, when you divide an expression, be sure to say that that expression that you're dividing is not 0, because then that would be marked on a test paper. As shown in the figure, a brick is placed in the right side of the balance, and half a brick and a weight of 2 kilograms is placed on the left side. This causes both ends of the balance to balance. What is the mass of one whole brick? So you can first rewrite this as, an equation. So the correct answer is D. Let me go over this with you. Let's call, so this kind of uses the practice we learned from the last lesson, which is setting up linear equations according to problems. So here, what are we trying to find? We're trying to find the mass of one whole brick. So let's call this x. Here, this is x, and this is 1/2 of x, right? Because this is 1/2 of a brick. So rewriting this, and this is the equal sign, so 2 plus 1/2 of x is equal to x. If you subtract 2 on both sides, so since we want the x's to be on the same side, subtract 1/2 of x on both sides. So we have 1/2 of x is equal to 2, multiply both sides by 2, and we have x is equal to 4. Therefore, one whole brick has a mass of 4 kilograms. If the values of algebraic formulas 8x minus 9 and 6 minus 2x are opposite numbers, so these are opposite of each other, what is the value of x? The value of x would be equal to 1/2. Let me go over this again with you, because you might be confused. So we know that they are opposite numbers. And also look for keywords in problems such as are or is, because that means equal. Okay. So because they are opposite, then 8x minus 9 is equal to, let me write this somewhere else. So are and opposite. So we have negative 8x minus 9, because remember they're opposite numbers, is equal to 6 minus 2x. Now again, all you have to do is solve. The main focus here is if you can combine this week's practice with last week's practice, put them together, and now you know how to list equations and solve them. And in the end, you can use linear equations to fully solve simple word problems. Let's discuss. Solve the equation 3x minus 3 is equal to 2x minus 3. Karen solves it like this. First, you add 3 to both sides of the equation. So 3x is equal to 2x. If you divide both sides of the equation by x, then 3 is equal to 2. But wait, 3 cannot be equal to 2 because 3 is bigger than 2. Therefore, this is not true, and there is no solution to this equation. So yes, sometimes equations have no solutions. Is Karen's problem-solving process correct? If correct, state the reason for each step, and if not, point out where it went wrong. So you can think of this by yourself, but since I'm not talking to you live, I can't exactly communicate with you, but feel free to solve this problem and write your own thoughts in questions, if you have any, in the in the comments down below, and then you can interact with one of us or one of the other viewers and talk about the answer to this problem. Class summary. Basic properties of linear equations. We'll learn about the properties of linear equations and how to solve linear equations using these properties. We learned how to understand we learned about the basic properties of linear equations, and we were able to use them, the property of equality, to solve simple linear equations. Thank you so much for watching through Inquisitive Kids. We really appreciate your support, and if you found this video helpful, please hit the like button and subscribe for more videos coming up. Remember, stay inquisitive and see you next time.